So we have seen the first hydrocarbon uh, that is methane. Methane tetrahedral. Yesterday I removed one hydrogen CH bond and I replaced it by another CH3. So this is ethane. Ethane. Only sigma bonds you are seeing. The single bond means that is sigma bond. This is CC. This is CC single bond. This is CH single bond. Then CH single bond. Then CH single bond. So you can see CH, CH, CH and CC single bond. Similarly here also. This is ethene. C2, C2, H6, C2, H6. So first one was CH4. First one is CH2, that is ethene. Second is CH3, CH3 bond CH3. You can write in this way. Or C2H6. You can write C2H6. So that is ethene. Ethene. Now, I'm going to replace one hydrogen by another CH3. So you see a bend structure, but this is a straight chain. This is a straight chain. So here CH3, this is CH3, then CH2, here CH2, see, like this you can see all carbon is under tetrahedral, all carbon is under sp3 hybridization, then CH3, like this. Here CH3 and here CH3 and here CH2. So CH3, CH2, CH3. Alright, so you look this like a bend one, but it is a straight chain. We call it as straight chain. So either you can write that as CH3, CH2, CH3. Or if you want to show only this bone line, that we show like this. This is propane, propane. This end remains 1 CH3, the other end remains 1 CH3 is understood. And this each term in between carbon, that is CH3. So this is propane. See, all carbon is under which hybridization means tetrahedral format means tetrahedral format means this is sp3 hybridization. All carbon sp3 carbon, sp3 carbon, sp3 carbon. Okay. Now I am going to replace one hydrogen by another CH. So you get a structure like this. You get a structure like this, that is CH3. This was our previous CH3. Then two hydrogen CH bonds here. Then comes your CH3. So again, it is, you see like a zigzag, but I say it is straight chain. This is what we call it as straight chain. This is straight chain. So straight chain can allow what it is, that is cyclic ones. Cyclic ones. See this structure I can do like this. Like this. So this is not straight chain. This is not straight chain. Free rotation is possible on single bonds. So what I'm showing now is a straight chain. CH3, then CH2, CH2, नीचे की तरफ CH2, then ऊपर की तरफ CH2, then again CH3. So CH3, CH2, CH2, CH3. Either you can show like this, like this. That is CH3, CH2, CH2, CH3. This is butane. Daily we are burning this in our gas stove. Gas cylinder में ये compound है, that is butane. Or you write it as CH3, CH2, CH2, CH3. Alright? And replacing one more. So one more, you consider it as brown only, a black only. I don't have. I have only this much. So here CH3, CH3, CH2, CH2. Then एक नीचे तो next ऊपर, then again down, then up. That is CH3. Again this is straight chain. So CH3 like this. It is like this. First CH3, CH2, then this CH2, then this CH3, then the last this CH2, then this CH3. So this is pending 5 carbons. But as the length of the chain increases, there is tendency to form like this. I can show this as a cyclo. I will remove these two. I will remove these two hydrogen and I'll connect them with a bond. So it will be a cyclopentane. These two carbons, those end carbons are connected. So this is cyclopentane. In cyclopentane, you can see, consider this blue as that brown only, black only. So cyclopentane, see the top one, up, outer side. The CH bond, outer side. This again outer. This outer. But this is this cyclopentane. Similarly, you can have cyclohexane, one with one more carbon, cyclohexane. Anyway, in all these cases, you see only single bonds, means sigma bonds. So cyclic hydrocarbons are there, straight hydrocarbons are there. So cyclic, this is cyclopentane. Now I can show one more. I am detaching this thing. This one is cyclohexane. Cyclohexane. Last year you learned benzene. On that benzene, each carbon carried only one hydrogen C6H6 it is. But this is C6H12. On each carbon, towards the outer position you see cyclohexane. But the cyclohexane again turns to form like this. Like this. This is like a boat form. We call it as boat conformation, similar to a boat. See, similar to a boat. Similar to a boat. You can see these two carbons up, these two carbons up, and the other four, that blue, two blue and two brown, that are in one plane. So cyclohexane can form a boat form, like this boat form, or it can form a chair form. This is the chair form. Can you see the chair form? Boat form can change into chair form. Chair means like easy chair. Here you can sit, here downwards you can keep the leg. Okay, this side you can keep this side you can keep your head. So this is a chair format. You can see that chair format. So the other one what I showed is boat format. I'll change the colors there. I kept blue color. So this is chair format. In this chair format, that blue is on the top and one blue is down. Towards the top blue, you keep your head. Towards this bottom blue, you can keep your leg. Beach may you see the chair format. Now the same chair format can shift to the boat format. Now you see, both the blue up, both the blue up. So this is like the boat format. So this is called the boat conformation of cyclohexane. This is the boat conformation, see? Boat conformation of the cyclohexane. And the same thing, this is at higher energy because this blue closer to each other. When this blue and this blue comes here, These two are very close to each other. So we say it's a flagpole of the boat. There is flagpole repulsion because they are coming closer to each other. But in the case of chair format, you see the chair format. Chair format. This is here only, but here one was there that is going here. So there is more distance between these two. That means no repulsion. So which is more stable, boat form or chair form? Which is more stable? See here, this is here only, but previously this was very close to this like this. Like this. These two are very closer in the boat format. These two, these two very closer. These two, this and this closer. So boat format में there is repulsion, but in chair format, I'm talking about cyclohexane. Cyclohexane, you have to show like this only. Chair, this is the most stable because this and this blue one carrying this hydrogen, blue one carrying this hydrogen. They are far apart. So most stable state means leads to repulsion, most stable state. So this is cyclohexane. Cyclohexane. So straight chain compounds are there, cyclic compounds are there, straight chain hydrocarbons, cyclic hydrocarbons. This is ethane that I showed you before. This is ethane. In this you see only single bonds, means sigma bonds. How many sigma bonds are there? 1, 2, 3, 4, 5, 6, 7. 6 sigma bonds are there. This is ethane. Now I'm going to show a double bond. A double bond. A double bond between two carbons. But at this stage, here it is 120 and 120 double bond. This is between two carbons double bond and all bond angles are 120. 120. This is 120, this is 120, this is 120. Here is double bond. If it is a triple bond, if it is a triple bond, then this is 180 degree, 180, this is 180, triple bond 180. So triple bond means one sigma bond and two pi bond. Double bond means one sigma bond and one pi bond. Single bond means only one sigma bond. hydrogen carbon. So here only this C, H, 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 C, H, H, H. Sigma, 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 sigma. How many sigma bonds are there? How many sigma bonds are there? 7 sigma bonds. But in the case of this ethene, this is a double bond. Double bond means one sigma bond and one pi bond. So this is a sigma bond and the top one is a pi. One is sigma bond and the other is pi bond. And this is sigma, this is sigma, this is sigma, this is sigma. So how many sigma bonds are there? 1, 2, 3, 4, 5. How many pi bonds are there? 1 pi bond. How many double bonds are there? 1 double bond. How many single bonds are there? 4 single bonds. 1, 2, 3, 4. This is a double bond. This is ethyne. Ethyne. In ethyne, you see a triple bond. Ethyne or acetylene. You see a triple bond. Triple bond is constituted by one sigma bond and two pi bonds. One sigma bond and this one pi bond, this one pi bond. This is sigma, this is sigma, this is pi, this is also pi. How many single bonds are there? 2 single bonds are there. How many triple bonds are there? 1 triple bond is there. How many sigma bonds are there? 3 sigma bonds are there. How many pi bonds are there? 2 pi bonds. So write one question. How many sigma and pi bonds are present in each of the following molecules? How many sigma and pi bonds are present in each of the following molecules? How many sigma? 1, 2, 3, 4, 5, 6, 7, then 3 is 10. So there are 10 sigma bonds. How many sigma bonds are there? 10 sigma bonds. Among that, CC sigma bonds are 4 and CH sigma bonds are 6. How many pi bonds are there? How many pi bonds? 1, 2, 3. There are 3 pi bonds. 3 pi bonds. Among these, pi CC bond 1 pi means double bond 1 and triple bond. In this double bond, 1 pi bond is there. In this triple bond, 2 pi bonds are there. So how many sigma bonds are there? Totally you can write. That is 10. How many pi bonds are there? How many pi bonds? 1, 2, 3. 3 pi bonds. Now, if the carbon is touching to only single bonds, then hybridization is sp3. If a carbon is touching a double bond, then sp2. If a carbon is touching triple bond, then sp3. So, predict the hybridization. So this carbon is touching triple bond. This carbon is touching triple bond. Of course, it is touching single bond also, but more number you have to see. If the carbon is touching to a triple bond, then it is sp. This carbon is also touching triple bond, that is sp. This carbon is touching single bond, double bond. So this should be sp2. Similar is the case here. This carbon is touching double bond, that is sp3. This carbon is touching only single bond, that is sp3. If the carbon is touching only single bond, then hybridization is sp3. If it is touching a double bond, then it is sp2. If it is touching a triple bond, then it is sp2. What is hybridization in CH3Cl? What is hybridization in CH3Cl? C, H, 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 Cl. Only single bonds are there. So the hybridization is sp3. Hybridization is sp3. Okay. Thank you.